Alec, were you here last week?
No, sorry, Pat. I forgot to tell you I was in I was out on the Channel Islands last week and
Yeah,
I
no,
couldn't
it's
make
a,
the class.
it's okay. I thought you weren't here. I just was double checking. What were you doing out there, you lucky dog?
I went camping for the weekend.
Wow, good for you.
Yeah, we went out there Saturday, Sunday, and Monday and camped at the Scorpion Bay campgrounds.
Oh yeah,
It was nice.
Did you have a boat or did you take the public boat?
I took Island Packers.
Yeah,
Um, and yeah, the weather was kind of overcast, but it was still really cool. I had never been to Santa Cruz before, so
yeah.
it's neat
They
out there.
that that island packer is pretty cool actually too. They they go where the dolphins are. Did they do that?
Yeah, we saw 3 humpback whales.
Wow,
Yeah,
that's cool.
yeah,
When
it
you
was
go
great.
to you can take that. Well, they drop people off at I guess it's Scorpion Bay, right? That's the drop off,
Yep.
and then they go around to they go on the windward side of the island around to Santa Rosa and
Yeah, I
drop
stayed
people.
there. Yeah, I stayed there a couple years ago. That's a really cool. I think I like that island better.
Yeah, isn't that nice?
Yeah, it was really neat.
Yeah,
Both are cool.
yeah. I wish I had a boat over the years. I just never got into boating, but that'd be a great thing just to go over there when you wanted to.
Yeah, we saw some really nice sailboats in the
Yeah.
harbor there.
Yeah, I'm sure. All right, well, let's start this gig, huh? 6:04. So it was pointed out to me by my early appearing students that there wasn't a homework assignment. And there wasn't last week, and I went to put it back on when I got home and it was on. So I didn't do anything, and then it turns out it's not on now. So we're going to go through all the homework page by page anyway, and I'll put it on tonight or tomorrow so you can, refer to it, go back to it. Okay, that's the best I can do. So let me pin myself so Miguel doesn't have to do the whole class. Okay, so you can see my whiteboard, yeah?
Yep.
Yeah.
Yes.
Yeah.
So MRV means minimum ventilation requirement. So there's well, all through modern history, in other words, the last 50 years, the building department, the government, is interested in people's safety, right, in their homes. So most of the code involves fire problems because that's the biggest thing that wipes out homes and people. And then when we started becoming conscious of air quality, then they started realizing ventilation was also an important thing to make sure people do right, to guarantee our health. So they've had these minimum ventilation requirements for quite a while now, 20 years, maybe more. And but as we get tighter homes, because we realize we learned how to, with blower door and such tools, we've learned how to gauge how leaky our houses are. And we found out that most houses are leaky enough to waste a lot of energy. And at first, we didn't want to waste energy because it costs money. And so we're looking out for our energy bills. And then global warming came on the scene, and most of our energy came from fossil fuels, which was contributing to that. So then we had yet another reason to make our houses more efficient. So now we have global warming, we have money in our pocket, and we have health, air quality, health. All 3 things are important now. So a lot of building performance revolves around those things. as you've seen, a lot of what we've talked about is sealing the shell and determining how leaky the shell is. So tonight's on ventilation. And so the government has a minimum ventilation requirement, and leaky homes leak that much. So they don't have, nothing has to be done. They leak enough so that the air is changing enough. But if we want to help global warming or save some bucks, then we got to tighten them up past that. Then we're not satisfying the minimum ventilation requirement anymore. So then we have to actually bring in air in where it used to leak in. And people go, well, why bother with all that? Why not just leave them leaky? Well, because of what we said. If they're leaky and we have to cool or heat them using fossil fuel, it's not good for the planet and it costs us money. So the other solution is tighten them up to deal with those things and then bring in air. And you can bring in air in better ways, and you can bring it into places that are more comfortable. Leaky homes, a lot of times the leaks are in places like, say, in your living room, say next to the fireplace. So it's a nice winter day and you want to sit in the fireplace, by the fireplace, and there's a big draft going right by it. So you keep putting wood on the fire and you're kind of warm, but then you're freezing from the draft. I lived in New England, and that's always the case there because they don't have any insulation or air barriers. So the old way it leaked was also not good for comfort because it inevitably leaked in places you didn't want it to and made life kind of miserable. So we can bring the air into places where it won't go right on us and make us cold. We can, with some of the devices that bring air in, we can recoup some of the heat that goes out because they go out right next to each other, and this device sucks the heat out of the outgoing air. And then we can also suck moisture out of the outgoing air and use that moisture back in the house in case you're in a dry place like Colorado. I lived in Colorado for a few years. Damn, the winters there are so dry. Everybody has big pots of water on the stove, just, humidifying the house. It's really dry. So those energy recovery systems, we'll talk about later, those are nice to have too. So it's gotten more complicated and we're doing more stuff, but the reason we're doing them are real reasons for the low global warming, to keep the planet from falling apart, to save us money because we're not all made of bucks, and to be more comfortable and to be more healthy. So the reasons are all good. So we're just going to put up with the all the science that's needed to accomplish all that. Okay, you got that? So you might have heard in some of these, you get bits and snatches of information from the different blower door videos or ceiling videos. So we'll keep repeating the stuff and clarifying because some of those videos actually have it wrong. The old MRV, and this comes from an engineering, there's a objective non-governmental engineering association that creates data and engineering requirements for the building department. It's called ASHRAE. I don't know what it stands for. ASHRAE, association, blah, blah, blah. It's got to do with engineering and air quality and that stuff. But they've always had this manual that HVAC people use because they were the first people that had to do with ventilation and heating and cooling your home. So originally it was, and it still is, but I'll tell you why we were getting away from using this. But essentially they say every 3 hours, all the air in your house should change itself out, should replace itself in 3 hours. And then they said, well, it's hard to work with something that's 3 hours. Everything's by the minute or by the hour. So let's translate air change for 3 hours into an air change per hour. So we just divide by 3. So one air change every 3 hours is the same as 0.3 air change per hour, a third of an air change per hour, right? If you don't see it mathematically, just take my word for it. So the real rate, because we like to do it hours, we like to do it single hours and minutes and seconds. 3 hours is not a workable quantity.
Is it 3 hours for every size house or certain size houses?
Every size house.
Oh,
Good question. And you'll see where we use the size of the house in determining what that ACH should be. So 0.3 ACH. So write that down, put that in your head. It's on a lot of the handouts. It's on the ones that you didn't see, unfortunately, but you'll get those this week. But I'm going to go through it. So just remember 0.3 ACH. That's all you need to work with if you want to. So there's a couple more formulas, and one is the blower door test works in CFMs, cubic feet per minute. And that's because you can't, it's harder to measure cubic feet per hour leaking. You can do it by the minute. A fan can monitor that and record that much easier. So they figured 50 pascals pressure is a really easy pressure to attain in a house. So we go cubic feet per minute at 50 pascals, which we set the blower door up for that. So we do have to convert CFM, cubic feet per minute, to air changes per hour. And we have a formula for that. It's just a straight math conversion. Sometimes we want the ACH in hours because of who we're talking to or where we're plugging it in. Sometimes we want the CFM, okay? So then, and I'll show you where those formulas are. You don't need to know them. If you ever need them, you can just go back to this data, or you can get them in books and stuff. So then the process that we're doing, and this is a repeat from last week, is we're figuring the minimum ventilation requirement for our house, for each house. If you're doing it for someone else, it's for that house. That will have to do, obviously, if it's a bigger volume house, it'll have a bigger volume of air, like Jack was asking about. And so that ACH will be different for a larger volume house, and the CFM, whichever one you deal with. So when we figure the MVR, we're going to figure it on the basis of the volume of the house as well. There's other factors too. It's, it's not, it's a little more complicated. It's not, crazily hard to understand, but there's a couple factors. We'll go through it. So you figure the MVR ahead of time for the house you're working on, and then you run a live blower door test like we tried to do a couple of weeks ago. Well, I got to tell you, Lewis was filming, so we stayed and we found enough batteries and another manometer, and we hooked it up and we got the test to work. But you'd all gone home and were asleep and drinking beers by that time, so I didn't want to make everybody come back. So I think it came to, do you remember what it was? It was under 900.
Well, what was the previous reading? I thought it was it 751 or 1751?
Yeah, I can't remember. I'll look it up. It's 17, because at one time I got 2000, I used it. Oh, yeah, it's usually 1800, and it came to 1740.
17,
think,
yeah, 50, I think.
Yeah, and I think it was down from the usual 18 because we got newer windows. Remember I told you?
Yeah, those 50, that extra 50 difference.
Yeah, that's not a lot. So those windows didn't help that much, but what the hell? They're quieter, So anyway, so we do our own test, and then we compare the two. We have a standard that's based on the size house and the number of stories. And then we take that figure and we compare it to what we actually got, and it'll show us whether we're tighter than the minimum requirement. Now we're working with minimum ventilation now, not with the data for, an energy efficient house. That was last week and 2 weeks ago. This is for just minimum ventilation. So we'll have what the law requires us. We have to have a certain amount of ventilation, 0.3 air changes per hour. And if we do our blower door test and we don't have that many, we have like 0.2 changes per hour. That's less, that's not enough. So we'll have to create more ventilation. So even
how do you create more ventilation?
By bringing in air from the outside. And that's what we're going to talk about for a lot of the class. That's coming right up. So, most of us will have houses that'll leak enough that they'll pass the 0.3 air change per hour. So legally, most of us are okay, and health-wise, we're okay because it's, any toxins we bring in or moisture that we've created is leaking out at a rate that's okay. It's just that if we want to tighten our houses up because we want to spend less money on energy and help global warming, then any way you tighten it usually brings you below that minimum ventilation. And then we have to talk about about bringing in ventilation, and there are a whole bunch of alternatives. So it's really great. So we'll do that in a second.
Just started sprinkling downtown.
Yeah, it was weird. I was telling Lewis earlier, we had one bolt of lightning. I was in my kitchen and just goes crack outside. And I run out hoping, oh boy, a rainstorm. And there was a few sprinkles. And I thought, nah, that was it. It went on.
Is it raining right now?
Out here?
Yeah.
Here's right here.
No, not in Goleta, or at least not where I am.
Okay.
Yeah. Good thunderstorm would be fun, huh?
Yeah, that would be great.
Who here has dogs or cats that are afraid of thunder? Anybody?
Some
I had a
pretty
friend-
fat raindrops.
I had a friend who had a dog, and every time it was thunder, he'd run under the bed and just shake. It's probably a smart thing to do if you're a dog.
Yeah, my dog does that. He runs to his bed in the room.
Yeah,
Or he runs to my lap.
yeah,
I'm lap dog.
right. I thought I'd catch at least one person. There's an ad on TV. It's really cute. I forget what it's for, but there's a thunderstorm and the dog jumps up on his owner's lap. It's a big dog, and the owner turns on, they have those calming TV stations for dogs. You ever seen those?
Oh, dog TV.
Dog TV. They have, rivers with trout jumping out of them or salmon jumping out of them and all these things that they think dogs like. It's a pretty absurd concept, but it's kind of funny. And then in the ad, the guy jumps on his lap and then he turns on the TV and the dog's looking at the trout, the salmon jumping, and he's like drooling, because fish. Funny ad. Okay. So let's go through. After we go through ventilation, we're going to look at what's it called? I'll think of it in a second. BPI, Building Performance Institute, and they go in and they'll test houses for minimum ventilation and for leakiness, and they also add a combustion safety test. And I want you guys to see what that is. It's really interesting. Everybody's doing it now as part of their energy thing. Maybe hers isn't, but it's not having to do with anything we talked about. It does have to do with safety, though. And I think it's really great. And the interesting thing is that it's the combustion appliances they test are natural gas and propane, because those are the combustions that can, blow up. Electricity doesn't combust, and it's safer. And since we're going with electricity, this won't even be an issue in 10 or 15 years. But for right now, it's still an issue. And this is really great because BPI, a lot of the stuff owners can do and owners can find out about in terms of the carbon monoxide they're producing in their house. So I always show it as part of this. So at the end, we're going to talk about these various associations that train people to do jobs like that, like HERS raters or a BPI system analyst or whatever they call. So this will tell you a little bit about what they do. And then toward the end, we're going to actually look at what that career opportunity is. Okay, so I'm going to share a screen. Now, can you see this is the same old thing, and I'm too senile to remember what we said last week. Can you see the little screen or only the whole bunch?
Whole bunch.
Yeah, I thought so. You guys are no fun. Okay, so what do I got to do here? Get rid of that. Now, I think if I just put one on the screen, it'll go to the, you can see that one, right? Leakage pressure. Yes?
We can't.
You
Still
can't?
no, still just the
No.
thumbnails.
God. Okay, I can fix that. We're working on it. No, here it is. Where's my little, no. How do I get my, how do I get my, oh God. So I can't get my, my gallery view big. Does anybody know what I need to press?
Hey Patrick, it's Michael Silva. Sorry, I just got done with work and home, and sorry I'm late.
Oh, it's okay. So,
I think I know a way to help you, Patrick. I think it's
Yeah.
an issue with your screen sharing.
yeah,
So in the bottom of Zoom, where it says share screen, if you
yeah,
click
but
on that,
I don't even have that. I don't have the full, I don't have the full, my full screen that has the little band on the bottom.
if you go back to your Zoom tab, I think it should have it there.
My what?
Your Zoom window, like where we all are.
Yeah, but it's not there. It's like I keep telling you.
Oh,
I can't make it bigger. I just have. No, and I don't have it on mine either. Oh, how weird is that? No ideas, huh?
Are you in
You know
like a
what
full screen mode
You
or
know what I'm
something?
saying? I have the gallery view, but I don't have a bar beneath it that's got stop sharing.
that might be at the top of your screen because you're presently recording or presently screen sharing.
No, it's not. It's not on the top of the. How weird is that? Well, I'm going to have to back out to do this. Okay, so just hang on. Oh, that's weird. It's back now. The way I had the screen sharing. Okay, I can get to it now. So
What'd you have to do? Hit escape or something?
no, I just got rid of the handout that was on the screen.
Yeah, I think it's because you're sharing one window at a time, and so Zoom locks you into that window.
Yeah, but here I've got one window right now, and I've still got the band on the bottom.
But I don't think you're being locked into it because you're no longer screen sharing.
Okay, so let's try this. Oh yeah, you're right.
You're showing.
Well, can you see the handout?
We can.
Yeah.
You can, right? But some like last week I did that, and I could, and the handout had an arrow. I could go to the next one, right? This one doesn't do that. So Hang on. I'm getting there. Okay, now. Can you see anything on the screen now?
No.
Okay, can you see this on the screen?
Yeah, we can see the handout.
Yes.
Okay, great. Okay, so this is from the book we're getting this stuff out of, and it's how to measure building performance leakage pressure. And we may have looked at this before, but I just want to show you, see, it's air leakage or ventilation can be measured under natural and powered conditions and in CFM or ACH. So that's what we were talking about. So this is the formula for changing CFMs to ACH. So say we got, when we did our CFM 50 the other night, say we got 2,000. I'll round up from 1,800 to 2,000. So we got 2,000. So you'd put 2,000 here, you'd multiply it by 60, you divide by the volume of our room there, which was 30 by 30 by 10 or 9,000. And if you did all that math, you'd get an ACH. I think it was, well, I can't remember, I did it on the side, but that's one way to find that. And then this has some standards for how that lies in terms of whether it's tight, kind of ordinary, or whether it's really leaky. I think it came to 13 if you did all that math. So we were more common, a little over the more common, but not quite big leaky, which makes sense for those kind of portable classrooms. So they used to figure it this way, and BPI does it this way also. This is the ASHRAE standard. This is where to look it up in the engineering manual. And it's 0.35 ACH based upon conditioned volume of house, right? And there's another way to figure it, and that is you take 15 cubic feet per minute per person that lives in the house. So if 4 people lived in that classroom, it would be 4 times 15 or 60. And 60 is greater than whatever this was. What I say, 37? No, I can't remember what I said. But 60 would be greater. So then we do it this way. You don't need to remember that. That's just the old way they did it. And whoa. No, it's just going to be painful. Okay. So you can see this one, second one?
Mm-hmm.
Okay, great.
Yes.
So this is building airflow standard. This is from, that's our same book. So sometimes they do it by square footage, which is kind of weird because you can have different heights house, you know, you can have really tall ceilings and that will add more cubic footage. So it's not even, so you have to make sure they're dealing with your square footage or cubic footage. See, this assumes they're 8-foot ceilings. So it doesn't work if they're not 8-foot ceilings. Then there's one other factor. So, and that factor is whether your building is how many stories your building is. Anybody think about why that's important? Well, you don't have to think any longer because here's the
Is
answer.
it because of the square footage?
No, that's a good guess. It's because when you have several floors, remember that pressure, the pressure on a house from different things, the stack pressure where the hot air rises or the wind pressure. So the more house you have that those things occur in, like if you have a 1.5 stories or 2 stories or 3 stories, the hot air is going to go up higher and it's going to be divided differently than a single story. Or if you have a higher building, you have more place where the wind can come in, can beat against the side of the building and come in. So what they do is they rate these number of stories, and I've seen different ratings. So this isn't an exact science yet, but this one, if we were doing our classroom, room 23, it would be single story. So we take 19 as the N factor, and that's going to figure into this right here. You're going to multiply the CFMs, the air change per hour divided by 60 to get minutes. Then you're going to use the volume of the house and you're going to get 103 CFM N. Then you're going to take that 103 and multiply it by that N factor, which we said one story was 19. Well, they're doing a 2-story house, so 15.4. And that's going to give you your final CFM 50. So that's your final number. And they want a target range. So they say take 70% of that number, which is the bottom number. And so anything below that is too tight. Anything above this is loose, but legal. So your house at least has to be this if you want to be legally ventilated. Okay, so there's a lot of formulas. I'm just showing you the old way they used to do it. But now we do it differently. Yeah, sorry about that. Hold on. So you see this page here?
Yes.
Okay. So this is on a government, an EPA website. So, and this is a couple years old, so there may be another one. But they decided that it was too hard for contractors and carpenters to deal with all that math and all those formulas and stuff. So they tried to figure out a way to make it simple to meet the Title 24, that's the building code, to meet the building code ventilation requirements, the MVR, right? So we're not talking about making a house tighter. We're just talking about making it ventilated enough to pass this standard. So they're going to do a house. I have some write-in here about our classroom, but let's just take the sample house they do. So they're going to give you a sample house, and they're going to run through how you do it. And it looks like more formulas, but it's a lot simpler. And so let's run through it real quick. So let's take it for an example, a 1,500 square foot house with 2 bedrooms. So step one is we have to assess the ventilation needs. So step two is to meet the local exhaust ventilation requirements. So that would be the state building code and the local building code if it's more stringent. So what they're going to suggest is using a kitchen range hood fan to act as a whole house fan to get the ventilation to where you want it, or a bathroom fan, because both of those are exhaust fans. So that's what they're going to do. And then step three is determining the airflow needed. So they take CFM, they want to find a CFM, so they take the floor area of the dwelling, they add the number of bedrooms plus 1 and multiply it by 7.5. Now this is all weird, so you don't have to understand it, you just have to go through the math. So say, don't look at the 900 in the pencil, that was our room. Let's just do the sample one they have. So you plug in 15 for the floor area, because that's what it is, right? 1,500 square foot house. Then you put 7.5 times, it's got 2 bedrooms, so that means 3. So that'll be 3, 2 plus 1 is 3 times 7.5 is, I don't know what that equals, but with the 15, it's going to come to 37.5. So that's how many CFMs you need to change in the house to meet the minimum ventilation requirement, which is, anybody?
0.3 air changes per hour.
0.3 air changes per hour. And if we converted that to CFMs, you could compare it directly. And we should, but I haven't done that yet. So, so they say you got to have that much air exchange. So choose a fan or a system, ventilation system that will provide that. So if you use an exhaust fan, which is the simplest way. So here's the thing, when you're remodeling a house, unless it's big enough, they're not going to check. If you have an existing house that you're living in, you don't have to do this because it's grandfathered in. No one's going to come and check your ventilation rate. You might want to do a blower door test to see how tight it is, because it may be causing you poor air quality problems.
How much do those cost to
How
have
much?
done by professional?
Gosh, I don't know. I can maybe call, I'll see if I can call a local tester and see what he charges. I'm going to give you more of that data when we look at that as a professional opportunity later, but I'll do that this week. So if you want to do a bathroom fan with 40 CFMs, that's higher than that, right? So you could use a bathroom fan and just leave it on all the time, and that will keep your house at 37.5 CFMs air exchange, which will meet the code. Now, the only problem with using a bathroom fan or a range hood fan is because they have to be on full time. If you get a fan that just meets the requirement, it obviously has to be on full time to ventilate your house. If you get a fan that has more CFMs, like twice this, then you can leave the bathroom fan on half the time, 12 hours a day, right? So you could have a timer that does, 6 in the morning, 6 in the afternoon, 12 hours at a shot. But if you just have a fan that's about the same, then you have to leave it on continuously because it's acting as a whole house fan now. And because it's on continuously, they don't want you to go crazy with the sound of a bathroom fan. Now, I know everybody in my audience tonight has gone a little crazy with the bathroom fan at one time or another. Is that not right?
How did you know?
Oh, thank you. Great response. Who was that?
It was Lewis.
That's great. Yeah, I mean, sometimes there, especially if you rent, seems like every time you rent a place, like an apartment or something, the fans just are so loud. So they are looking out for your mental health. And so they say you can't have one of those. There's a sound rating, that's the sound rating. And usually they're 3 or 4 or more. And for a bathroom fan,
Don't they make bathroom fans loud on purpose, like so that when you're like taking a shit, you can't really tell? I heard that's a thing.
You know, maybe, but I think that would be a good reason. But I think it's more to do with
Yeah.
money. I think it costs a lot more to make them quieter. So that is a good reason, though. But and that may be a reason for not wanting to get a. Well, actually, they require it if they know. If you're just doing this because you want minimum ventilation because you think it's healthy and you're not even going to talk to the building department, then you could go along with your noisy fan. But 24/7, you'd hear that bathroom fan. If you get it down to 1 sohm or less, fan must be certified 37.5 CFM in water closet with sound rated at 1 sohm or less. And it will cost you to get a quieter fan. But when you're dealing with your whole house minimum ventilation requirement, as a solution, that's still relatively cheap. You get a fan for maybe a couple $100 at the most because they're more expensive with the less sound. That's still a cheap solution to get, minimum air into your house. You can also use a range hood fan, and those they want providing 100 CFM, which is more closer to what they provide, and those also have to have at least a 3-point zone rating at the lowest speed. And then you can always put in systems that use your ductwork in your existing HVAC, or you can use, you can just have inlets that bring in ventilation air. We're going to talk about those next. So let's look at the rest of what the government has, making it easy for us. That would be 4, which would be okay. So this is kind of repetitive. It's so typical government. It's not just short and sweet. They go over and over, and it's almost more confusing that way. What can I say? So they're saying, okay, let's ventilate right. That was kind of an overview. Now they're going to do step by step. Okay, so you have to assess the home. Do you have a range hood? Is it ducted outside? Does each bathroom have an exhaust fan? And you answer all those questions. And then our combustion appliance is present. So this is talking about ventilation in general. Anybody know what gases come from combustion appliances? The
Carbon
combustion of,
monoxide.
yeah, propane and natural gas have carbon monoxide, and if they're combusting properly, efficiently, they don't have enough to make a problem. If they're not combusting efficiently, and I'll show you a bunch of ways that make them not do that, you could be getting a shot of CO that's not only it's either deadly or it can make you really horribly sick. So so they include that in ventilate right, because they want you to ventilate in terms of combustion also. But let's go on. That was 4, right? No, let's skip 5. See what 6 says. 6 says nothing. Let's go on to 7. Oh yeah. Okay. Okay, step 3, vent right. Determine the airflow required for whole building ventilation. That's what we did at that first page, right? And here's the formula in all by itself. The whole building continuous ventilation rate in CFM is the floor area I think that's over 100. They forgot the line there. I don't see a line, do you? Another mistake by the bureaucracy. That should have it should be over 100. Plus the number of bedrooms plus 1 times 0.75. Okay. They also say you can either do that math if you're really industrious, or you can actually use a table. But the table is not as accurate. But say we're doing the house at this model house, so it's 1,500 square footage, and it had 2 to 3 bedrooms, I think. So they recommend a fan that does 45. What was the fan when we did this earlier? What was the number it came up with? Anybody? 37.5, remember that? Is anybody there?
Yeah.
Yep.
You liar, you liars.
Do we calculate this a class or two ago?
No, just 15 minutes ago. We did that formula and it had the bedrooms. It was this formula.
Oh, it was 37.5.
37.5. So this one says 45. So it's a little higher. So if you use this, you'd have to get a fan that did 45 or 50 CFM. And when you could get away with if you did it with this, it'd be a little more accurate and you can get away with a 40. So this is easier, but it tends to be a little higher. So that's the difference in those. And then maybe just a few more of these. What was that, 7? No, it's 8. Okay, that's worth looking at. Nope.
Patrick, as far as sound goes with any of these options, wouldn't it the best thing to do is put in like an attic fan or something upstairs with a silencer on it? Or
Yeah,
something?
let me. Are we recording?
It looks like it.
Yeah.
We are.
We'll talk about that in a second. Okay, hold that question. That's a good question. But I want to go through these things. I want to finish this and then we'll get to that. So here's step 4 of this guide. Let's see. This is the can I get it on there? Yeah. This is the URL. Resave guide. What do you suppose that is? Yeah. I don't know, but it's government / step 4 whole house. So anyway, it's a government. If you looked up whole house ventilation requirements, you'd come to this page probably. So choose the whole house ventilation system type. This is going toward Lewis's question to provide at least the airflow calculated in step 3. So you got 3 choices: an exhaust only ventilation system, which is what we just looked at using the bathroom fan or the kitchen fan. Supply only ventilation system, and that could be like your existing forced air unit, because that supplies ventilation, right? So you can use that, and then a balance system, so when you exhaust, what does that do to the pressure in your building?
Gives it negative pressure.
No, if you're pushing air out, yeah, you're right, negative pressure. If you're supplying What does it do? Say the
Positive.
opposite. It pressurizes your room. When your exhaust depressurizes your home, where do you think the air tends to seek equilibrium, right? In terms of pressure. So where do you think the air goes or comes from if your house is depressurized from exhaust fans?
From the outside.
Yeah, it's from all the
Bunch of
leaks in your house. It sucks air into the house through all the leaks. Supply side is just the opposite. It pushes the air out. If you have your ductwork and your fan and that works with your heating system, it will push air into your house, and then that'll have to seek lesser pressure, so it'll go out through the cracks. So a balanced one is better in many ways, but let's keep on this and we'll show those. Exhaust only ventilation system uses a single point, blah, 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 blah. If fan is located in the living space, the fan must have a sound rating of 1 son or less. Single point exhaust only ventilation system is a bath or laundry room fan set to run continuously at a low rate or intermittently at a high rate. So you can run it less than 24/7 if the higher rate is, proportionately more. Same with kitchen fan. It said 3 son up there, but that has to be 1 son too. The same thing. Your kitchen's even more obvious because you can at least shut the bathroom door, but kitchen's near your living room and you have to listen to that all day. A dedicated exhaust fan for the whole building ventilation, and then ducted inline fan dedicated to whole house ventilation. Then you can have multiple point exhaust fans, so you have many different places that bring in or push out the air. Let's see. Okay, that is. That was what we just looked at, right? So we want 9. Oh yeah, okay. Okay, so supply only. Let's see if we can get it big enough to read. Supply only systems use a dedicated fan or the air handler for the furnace or air conditioner, plus appropriate controls to provide whole house ventilation. Now, if any of you have a attic or basement air handler, a forced air system with a furnace, on your thermostat in the house, there's usually a fan only control, right? So that's what you use. You don't want heat or cold. You just want the fan's connected to the outside. It brings in air, passes it through the heater or cooler, and then into your house. So if you just run the fan, you're just getting air from the outside. Sometimes people don't like this because there might be insulation in the ducts. If, they weren't wrapped properly and somehow the ducts get insulation, it compromises the fresh air. It brings outdoor air in the house. Same thing. That's got to have a zone rating too. Usually whole house systems are pretty quiet, right? Because we're used to using those in winter. People have cold places. People have them on all the time. And so they're usually pretty quiet. And why are they quiet? Okay, if nobody answers me in 10 seconds, you're all getting Fs for the day.
For comfort while you're in the house, so it's not annoying.
Wait, why is it quiet? You want it quiet. Why is the air handler quieter than your bathroom fan?
Engineered better. I don't know.
Well,
Insulated.
where is it?
Well,
not in your house.
It's not in your living space. It's in the attic or the basement, or could be in a closet, and those are noisier, but yeah, if it's in the attic, you don't hardly hear it. Some of you guys must have forced air, right? Heating,
Yeah.
and have used it, and it's not very loud. It's pretty, sometimes you can't even tell if it's on. That's why you gotta keep walking under the vents to see if it's actually working. So that's good. So that's one nice thing about that, is it's quiet.
It's loud if the furnace is in the middle of your place, like mine.
It's in a closet in the,
Yeah, in the
Yeah.
middle of the house, so you
Yeah.
can hear it.
right. So the older ones that have it in a closet are, yeah, exactly. Okay.
Like a split system meaning cooling systems, like the
Like the heat pumps.
outside.
Yeah.
There's fairly
Ooh,
loud.
there's some lightning in Goleta. Thunder. Yeah, we'll talk about,
They're like crazy in upper state right now. It's setting off all the alarms.
yeah. We'll look, we got a whole video on heat pumps, actually 2 videos. So we'll talk about that later. Those are really great. And they bring in air from the outside also. And then they heat that air. They actually use the heat in the outside air. They suck it out of the air. That's how a heat pump works. So you're getting air from the outside into your house when you have those, and those can be in, mini rooms or your main area. So, but we'll talk about that later. We've got a whole unit. So before we get to those, let's finish this off. Central fan integrated system. So what I was going to say is, the building department's not going to come to your house right now and make you have 0.3 air changes per hour in your house. They don't do that. It's grandfathered in, whatever it is. If you have a remodel that's above a certain percentage of your house square footage, then they may make you upgrade that to then they may make you test it and make sure you have a 0.3 air change per hour minimum ventilation requirement. That's the only time they would know if you're doing a big remodel. If you're doing a small remodel and they're not involved, or they're involved but it doesn't make you bring things up the current code, then you can do it if you want to do it yourself. Like if you're worried about the health of your air quality, then you can do that yourself. However, in a new house, those are being required. In fact, they're gonna pretty soon, if they don't already, it's on the book, it's on the chopping block. They're going to require minimum air change per hours in homes as part of the building process. So you'll have to get a blower door when your house is finished being built, a new house, and it will have to pass that 0.3. It'll have to be above 0.3 CFMs. So for a new house, but also in a new house, you can do a central fan integrated system much easier, right? Because nothing's in the way. So new houses can use all the new technology that's much better than what we have to do when we remodel or upgrade our existing home. That's what I'm trying to say. So, that would be, they have, whole house fans that they put at the top of stairs or in inconspicuous places. And they'll just keep your house at, anything you want. Minimally, they'll do 0.3 air changes per hour. They may do more if your house is really tight, if it's made tight, and you need that. But so the fan will operate more to make sure it's still guaranteeing that 0.3 air changes. Got that? Of course you do. So you may be wondering now why you're learning all this. Because you've got a maniac for a ex-department chair. No, the reason is because, a lot of you are just grunt carpenters, first level laborers or apprentice carpenters, or, we have some full carpenters, but a lot of you are just doing carpentry, right? And it's your bosses and companies that take care of the and architects that design the homes that deal with that. But all your houses are gonna be this way pretty soon. If they're not now, but the code's gonna require this. So you really need to learn this. Plus for your own house and your own air quality and stuff, it's good to know. Let's see, what is 10 here? Oh yeah, okay. Oh, I hear that. You can't hear it maybe. It's grumbling out there.
Oh yeah, it's super nice. Reminds
I
me of the
love it.
Midwest.
Yeah, I know, it's great. God, the things we do without, amazing. Okay, I think this is near the end here. So a balanced ventilation system is good because your house won't have a positive or negative pressure forcing air in and out of it, right? In and out of the leak. So if you built a really tight house, then you don't want it to be negative or positively pressured and not able to relieve itself one way or another. So you can guarantee that from the beginning by having a balanced system that deals with that. Now, we're going to talk about these two things: heat recovery ventilator and energy recovery ventilator. These are important things to know. So, especially in cold climates, when I lived in Maine, I lived in Maine in the 80s, and these were being sold back then. So this is only new to the West Coast and that, but northern climates have had these for a long time, because when they would exhaust air out of the house, it would be air that they spent a lot of money heating. And I mean, you spend a lot more money when it's cold out because the air is 32 below. That's the air inside your house until you have it heated. So it takes a lot more heat to make 32 come to 62 than it does to make 62 go to 62, like where we are. So, people got tired of losing all that air, right? That conditioned air. So they came up with these, we used to call them air-to-air heat exchangers, but now they call them heat recovery ventilators. And it's just a ventilator, a fan in the wall, and it's got a, what's the name? A heat exchanger, but it's like two, like in solar hot water, it's got two coils that kind of are interwoven. So the heat, when the air in the heated air goes out, the heat is transferred across the membrane of this machine to the cold air coming in, and all of the heat from the air going out goes into the air coming in. So you don't spend as much money heating that air because you're getting a boost from the air coming in. So that's what those are. And the colder the climate, the more important it is, obviously. We don't, it doesn't get cold enough here. People are putting them in because they go with ventilation systems, but it's not, we don't lose that much heat, I don't think. Well, anyway, you can think about that as we talk about it. But the second one is an energy recovery ventilator. This is a newer invention. Does the same thing as the HRV in that it recovers heat, but it also recovers moisture, which is really clever. So part of the problem, like I said, if you live in Montana or Wyoming or Colorado, I don't know about places east of there, but in the Southwest also, New Mexico, really dry in the winter. And so you're sending out, you're ventilating, right? And you're sending out warm air out to the outside, but you're also sending out ventilation because you breathe and shower and do dishes and all that moisture, all that moisture is in the air. So when it goes out, you lose the moisture too. So this machine recoups moisture and heat. So that's really great. So you're not losing a lot of moisture. It's being recouped as the new air comes in. So in those kind of places, these are where it's dry. This is a must. You just got to have one of these. And they're not so expensive, they're reasonable for what they do. it says at the bottom, since most California climate zones don't include hot, humid, or extremely cold conditions, HRVs and EVRs operate with very similar energy efficiencies, which means you might just want to go with the HRV and then view the pros and cons of using. So I don't know if that's not there's no place where you can go, but you can look that up. You could just say HRV compared to ERV and go to those websites.
Hey, Patrick, I've got a question for you.
Sure. I thought you'd never ask.
So there's this place called Quail Springs that we.
Yeah, I know where it is.
Okay. So they have some cob houses out there, and they have one of them at least has this like natural air conditioner that they made, where it's basically just a pipe that goes underground. It's down a certain level, so
Yeah.
the incoming hot air, this is out past Ojai. The hot air that's over 100 degrees will go through this pipe and go underground, and then by the time it goes into the cob house, it actually cools down.
It sheds its heat in that earth, or the earth around it on its way in. Yeah,
So is that similar to what you were just talking about?
yeah, except that's a natural system, and I think that's better. That's a passive system, no electricity involved. There might be a slight fan, but the earth ships in. Did we talk about earth ships?
Yeah, we watched those videos. Wasn't that the same concept? They had
Yes.
those big
Yes, that's what.
ducts in the wall where the hill was built behind the house.
Yes, exactly the same concept. So, you can do it in a cob house, not an earth ship, or you can do it in an earth ship, but that is so fine. And you can screen it and filter it so so if there's anything in the air, and obviously you have screens so you keep animals out, insects out. But I think those are phenomenal. But they don't go with the kind of building we do in Santa Barbara County, right? Especially in the city. So, you got to get a bunch of hippies together out in Quail Springs out in the middle of the desert to do this stuff, and same thing with Taos, out in Carson part of Taos. And
Well, it's because they don't let you build cob houses here in the county.
I know, when the whole world goes gaga and blows itself up, there'd be people living in Quail Springs and Taos just doing the same old shit they always did, and they'll be fine,
Even out there, technically, they're not supposed to build cob houses because it's in Ventura County.
No, I know. The nice thing about counties is they're rural counties or rural areas of counties is they're real lax in their regulations. They know rural people won't put up with too much shit. So it's often been the case. I don't know if that's changing, but that's why people in my generation, the 60s, we did a whole back to the land movement. And I was late. I did in the 70s, but I moved to rural Maine and built as I wanted to for the most part. It's a lot of fun. You learn a lot. And, for the future, we're going to have to revisit all that stuff because we're just not going to have the damn resources we have now. And nobody seems to care about that. But I'm glad that Alec and you know about these things and are making the connections, That's what we want. And the Green Building Cast will even go more into that. We'll look at a lot of those.
But I was thinking about all that when I was at Costco today.
Yeah, I know. I hear you. The Arabs they've lived in a lot of hot regions like North Africa and Saudi Arabia, desert regions. They have a lot of cooling ideas also that are really, involving towers. And they were the first ones to use water like pools on the windward side of buildings with windows, and then the wind blows across those water pools and cools off. Brazil uses those. The whole capital of Brasilia has those. But, there's places all over that have these really great ideas. And the Arabs have lived for 1,000 years trying to keep these damn desert homes cool. And they've got great ideas, so we need to, and there's people that are keeping those alive too. Thank God. There's this guy in, I told you about in, Earth Institute. No, what is it? The one out in, what is that? The Adobe, the super Adobe houses, Khalili's thing out in Hesperia. Kaller's Institute. He was Iranian, but Iran's the same thing. It's a lot of desert and dry and hot areas in Iran. And he combined North African and Iranian architecture and used some of those same cooling systems. So that'd be a good visit to go to Hesperia. And, you know, if we could figure out for this building green class, if people could maybe not go a couple Saturdays and then save up for a good long Saturday to go out there, I'd be willing to do it. It takes about 3 hours to get out there. You know, it's above San Bernardino, and it takes about 3 hours back. And so 3 hours there, that's a night, you know, or 2 hours there, that's a 8-hour day. So, well, we'll talk about that. It really got some great things to learn from. Okay, so I really love you guys bringing in stuff you've seen, because it's all part of this. And you can tell that the way we're doing it in urban construction in developed countries is very active in the sense of a lot of electrical stuff, a lot of computerized stuff, you know, and maybe that's not the ultimate way to go. Right now, we have to do it this way because, you know, that's the way you have to build to survive in Santa Barbara County right now. I think we're done with that handout. And I'm going to skip that handout. And this is, okay, let's try this. We can only try and fail, right? Can you see that building performance?
Yeah.
Okay, great. Now this one I can flip, and it has to do with how I scan these. When some of them I scanned earlier before my wife had her scanner that will take a whole stack. When I did scan them one-on-one, then they don't sequence on this one on the canvas. But can you see the arrow where my arrow is? The next arrow on the right here?
Yeah, we can.
Yeah, so it appears when you can do that. So this must have been scanned on my wife's scanner and then entered as a whole. So some are that way and some aren't. So I apologize for taking the time. This will go faster. Okay, Building Performance Institute. Let's go through this and then we'll take a break and then we'll look at a video or a slideshow. And I can go through that if we're tired. I'll go through it fast. BPI, we're going to look at this as an organization later, but this particular analysis they do is done by this category of trainee called Building Analyst Professional. And I actually I took this training to find out what it was about. And so I have this for whatever it's worth. But so they're really into safety. They start out talking about safety for the person actually doing the testing. So it's typical, how to use all these things, how to use material safety data sheets, how to find out if asbestos and lead and mold are in the house and all that kind of thing. So let's go on. Respirators with filter cartridges must be worn in areas with exposure to air mold. So, they cover that. Carbon monoxide, they have a whole thing on evaluating the ambient carbon monoxide to keep their testers healthy when they're testing a house. So when they go into a house, they have what's called an ambient parts per million ppm CO, carbon monoxide. And it's just something they wear around their neck. And if any atmosphere they're in, like a combustion zone, which would be like where the water heater is located or anywhere in the house for that matter, if that thing goes off, starts clicking, it means that they're above 33, what is it? I think it's 335, I'll look, parts per million, and that means it's dangerous. And they turn around and go out and they tell the client that you've got to have your appliance maintenance people come in and work on the appliances to get it down, because it's not safe for anybody to be living in that ambient CO degree. So that's pretty cool. You know, they probably saving a lot of lives doing that. People don't even know because you can't smell it, you know. Let's see if there's anything on this page I want you to pay attention to. Oh yeah, preliminary and post-installation safety inspection of all combustion appliances must be completed whenever changes to the building envelope and or heating system are part of the work scope. And then the combustion appliance safety inspection includes carbon monoxide test, draft measurement, spillage evaluation, worst case depressurization. We're gonna look at each of those in a second. In homes with natural gas and propane, the lines have to be tested to make sure they're not leaking too. And then when they have a reading that's not good, they have to follow up on the appropriate things they have to do. Okay, let's go on. So gas supply safety, you just have to go to all the joints where a flex line hits another kind of line or a fixture. You do a regular gas test. Some of you may already know how to do that. You take a liquid with soap bubbles in it and a little sponge applicator, and you put those around the joints. And if it starts bubbling, you know there's a gas leak. You can also take a gas detector, you know, an electronic detector, battery powered. And usually you go in there first with that, and then they'll detect any gas in the area. And then you go in with the liquid soap and find out exactly where the leak is. So you do that with all the flex things. If the flex thing, they all have tags, flex lines. And if the tags say earlier than 1973, then you just have to replace that altogether, because they don't trust those lines to be either unkinked or uncorroded in that length of time. This is the combustion safety test. I won't go into it because it's pretty detailed, but this is what they measure. And this you might write down or try to remember. I'm going to probably have something on the midterm, but I will review it the week before. I think that's next week. Spillage is when the draft is going the opposite way. And so the air, instead of being drafted out, being vented out, say with a hot water heater, it's actually coming the other way. And if it's coming the other way, it can actually push the flame. You know, you have that little visible thing. They're making them different now, so they're safer, but it can actually push the flame out of the hot water heater. And if there's anything combustible, it can start a fire. So when it pushes the flame out, it's called backdrafting. And but just the presence of gas going the wrong way is called spillage. It's like spilling, the gas is spilling the wrong way. And you detect spilling with a mirror. You put a mirror up in strategic places that they teach you. Like in a hot water heater, it's right at the top where there's a little cup-like thing, and then it goes into the, there's a space, and then there's a thing that takes the gas up the vent. And you take a little mirror and you can see the moisture, the spillage, the gas coming back. And so you'll know there's spillage there. And then you have to check the draft of all the ventilating pipes, make sure they're drafting sufficiently. Sometimes you can even go in and look at them if they're not pointing up away from the appliance. If they start to go down anywhere, that's no good. The gas won't go up. So you check all those things. Then you check the CO, the carbon monoxide. You have a gadget that reads it, and you check that. And then you check the worst case spillage, and that is, you know, say you have you have a lot of exhaust fans in your house. You've got say you have 2 bathrooms with exhaust fans. you have a kitchen exhaust fan, you have a dryer exhaust fan, right? And you may have a whole house HVAC system that has an exhaust fan. If all those fans are on, what happens to the house again? Somebody said it the first time. If you're exhausting through fans, what happens to the pressure inside the house?
Depressurizes?
It depressurizes. So it's looking for air to fill in that negative pressure. So where do you think it's going to get? Where do you think the easiest places to get air are?
Well, from leaky houses from outside.
From leaky houses, but it's even easier through through actual material vents. So like it'll draw through a fireplace. The fireplace is open, it's just going to suck air down that fireplace to equal the pressure. Or if you don't have a fireplace, it'll suck air down the hot water heater vent, right? So when that air comes that way, that's spillage, and that's going to maybe backdraft flame into your combustion area and light the house on fire, light something close by on fire. And people put
Does air go through sewage vents, or is that a closed system?
No, you can get, let me see if this answers it, if I understand you. You can get hot water heaters that are closed systems and those are great. And the pressure in the house doesn't affect those. So those are much safer.
What about like toilets and sinks and stuff that's not necessarily hot water?
No, those are okay. I'm talking about air. You're right. I see what you're saying. Yeah, just air.
Yeah, okay.
So any kind of exhaust. So when you test this, there's a whole procedure of which combustion appliances you test first. You have to close doors in the interior, which add to the pressure. You have to figure that out. They'll train you how to do that. You start with the smallest CFM and you test it, and then you do the rest. There's a whole procedure, and you've got your manometer from your blower door, that little computer, and you have a line going somewhere else that's got like an outside air, and then you've got the other thing measuring inside air, so you can see the difference in pressure. So there's a whole process to that, and we don't need to learn it, but that's what you learn if you take this training. And you just go through it, and it tells you if they have all the fans on at once, which is extremely possible. People are using the bathrooms at the same time. Somebody's cooking in the kitchen, the vent hood's going, and somebody's washing clothes. That's not an extreme scenario at all. All that may put enough pressure that it's dangerous for backdrafting, and this combustion safety test by BPI will tell you that. And then they'll tell you that you have to do something. Isolate one of the combustion areas so it doesn't steal air from the house. There's various ways you can correct it, but it makes your house safer by doing that. So I think that's good for, this tells you the ppms as you're doing various tests. If it gets past 100, no matter whether the testing works, you have to stop work because that's 100's too high. So anytime it's over 100, you stop work, and you have to have the system serviced by an outside person. So they have those kind of tables. 35 ppms. I'm sorry, that's the ambient. If you're wearing a little meter and it starts going off, it means in the area you're working, the ambient air has 35 parts per million or more CO, and that's bad for you. So you don't have to panic, but you need to get out of there, and you notify the homeowner and tell them what they can do to correct that. CO is dangerous. People die every year from it. Often in really poorly built shelters, which would include trailers, trailer parks, old ones that have, just the worst equipment. And a lot of times those heaters are in such bad shape that they just spew, they spew carbon monoxide. And if it's hot, you can have the windows open and it probably won't quite do damage. But in the winter when it's cold, you're closing up all the windows and then you're just seeing that stuff in. People die in trailers all the time or get sick. I've had students that have gotten sick in trailers or what do they call those?
Mobile homes.
Mobile homes, thank you. Yeah, so there's all kinds of things you can do. Separating, if you have a combustion zone in your garage, and it's attached garage, you have to make sure the seal in the door between the garage and the house is really well done, that the seal doesn't let any air out, because you could get CO or some kind of other gases from any combustion thing, and you don't want it to get in the house. So
Is
that
it
door
required for new construction on garages to have
Yes.
insulation for exterior
Yes.
walls?
Well, I don't know about about the walls, but well, if not in the garage walls, in the wall, the common wall between the garage and the house, because that's the
Yeah,
outside
because we're
wall.
doing a remodel right now, and like every single wall that is just the garage, it's not insulated.
Yeah. I think you have your choice of doing the garage and not the wall between, like say you're adding a garage and you don't want to tear apart that wall. It's stucco and you don't need to. Then they would just insulate the garage, but the door's not insulated. So that's not very good. But yeah, what really matters is that wall between the garage and the house, because that's where your heated space is.
Can't get an insulated garage door. They don't have them.
Yeah, they do. And I think a lot of them have insulation, but it's probably a pretty thin piece of rigid. So and garage doors are pretty leaky too, right? The sides, they can't get them too close. And, they have weather stripping, but it's a garage door, right? They've got to have enough space to make it never stick and get screwed up. So
I think
Well, I
they
think-
recommend a fire rated door, Patrick.
for the garage, for the door into the house. The door into the house has to be fire rated if you're if the remodel's big enough, or in a new house, of course, yeah, that door has to be fire rated, because often your combustion appliances are in the garage, and if they set fire, you don't want that fire to spread to the house. So you have a door, it's just a thicker door, right? And solid, it's not empty. So it'll take time to burn through it. That's all fire rating is. It delays fires. It doesn't stop them. So you have to have double insulation too. You have to have fire rated walls as well between a garage and a house. Okay, so that's all for that one. And let me see if we got any more on those. No. So we have a film on indoor air quality, but it's going to take us too long. So let's take a 10-minute break, and then we'll come and look at a video on passive house. So passive house is a movement started in Germany, because Germany's cold, and and they have an engineering mentality. And so they started figuring out how to make these houses that are really tight, really insulated. They're so warm, you don't even need any heater. They say invite a couple over for dinner and you'll have enough heat to heat the house. And so we played with it for about 20 years, because it's different, it's German. It's got, they even changed the name from passive house to passive house. But the movement's starting to take hold here, because we're going in that direction anyway, with the new codes and trying to minimize the energy we use. So people are going, well, maybe that's not a bad system to work with. So there's more and more people. So I attended a webinar, and I'll show you a slideshow. We'll go through it quick, but it might be interesting to see what they do, because that's what we're looking at. We're looking at insulation and leakage, in general. So these are whole concepts for doing a house that way. Okay, 10 minutes, 7:41, 42, 45, so anywhere in there. Yeah. And we'll come back and look at that real quick.
Sounds good.
All right.
Hey, Michael, are you there?
Yeah, what's up?
Hey, so you know how we were talking about that asphalt layer in Rodney's class
Yeah.
and pouring on it? We excavated on Saturday morning and found out it's actually just like a compacted base, like road base layer.
Oh, really?
Yeah, so that's chill, right? To pour on.
Yeah, no, I would, yeah, that, I mean, yeah, just water it, water it good for a couple days, and I'd pour on that, no problem.
Okay. Cool.
Yeah. Yeah, as long as it's not actual asphalt, because it's gonna suck. Yeah, asphalt would just be bad news. But yeah, road base I would be fine with. We normally go with like AV, like gravel or AV decomposed granite and just compact it as hard as we can, then pour right on top of that. And it gets to the point where it'll get so hard that we can't even drive a metal pin in it. We gotta drill pins in. So, but I mean, same thing with that road base. So yeah, I wouldn't worry about that at all.
Wait, you guys will actually buy decomposed granite to pack underneath, or it's just like you have it on site so you use it?
Normally, so we also dig swimming pools, like just the hole for pools.
Uh-huh.
So sometimes it works out where we'll be digging a pool in one area and they'll get 3 or 4 dump truck loads of decomposed granite. And sometimes they'll bring it to my house, or other times if we need it on a job, if we have like crazy elevation differences of forms, then we'll use that to put down before gravel. And so just raise it up so we don't use as much concrete, but it all just depends. We get a lot of our fill dirt from digging swimming pools, so it's just different areas have different types of dirt and different types of rocks and different layers and everything. So all just depends how it works out.
Isn't the decomposed granite expensive though?
Yeah, no, you can sell it. So like if we wanted to, we could sell it back, but you gotta make sure that it's super clean and it's legit and not legit, but like, it's clean. Doesn't have a bunch of rocks in it, like big rocks and everything. But yeah, it's expensive.
That's why I'm surprised that you'd use that.
When we're digging pools, because we run conveyor belts, everything else falls into the conveyor belt from just past loads and everything, that it gets so dirty that, I mean, we could sell it, but it'd be more work to sell it and try to clean it all and get it all ready to sell than it would be to actually use, if that makes sense.
Yeah, because you'd have to sift it or something like that.
Yeah, exactly. So normally if we find it, because I live on property, we'll just dump it at my house and use it wherever we need it. Or if we have a job not too far and we have forms that are really deep and we just want to fill them in, we'll use that and just compact it for a long time and gives us a good base.
Because how much is that? Like a scoop? Do you know?
Decomposed granite. So normally they like judge everything by yardage. And right now, all the prices of everything between concrete, between bark, between regular topsoil and regular fill dirt, decomposed granite, it's changing so much that I don't even know.
Right.
Yeah, it's so hard to say.
I feel like it would be at least double or triple, what it would cost for sand or gravel.
Yeah, no, it definitely is. I haven't had to buy it in a long time, so I don't even know. Normally we just get lucky, but I mean, around me, there's the layers of the dirt. It's really weird. There's a lot of it up here. We hit it a pretty good amount, so we never have to buy it. But it's expensive though. Works great though. It compacts really, really good.
I wonder what would be a good alternative to decomposed granite, like for paths and stuff like that, that is still permeable, because we use it in our garden. And I mean, it still gets muddy and the water just runs off of it. So it's not very permeable.
Yeah, no, that's something that I don't fully know just because I don't work with that very often for like that application. But yeah, I don't know on that.
There's another type that we've gotten. It's called like Buellton shale or something like that. And it kind of compacts down the same as decomposed granite, but it's a darker color.
Okay.
But that's kind of the same thing. It's not very permeable.
Yeah, no, it's almost like you need I don't even know what to call it, layer on top of the decomposed to kind of take all the water away and keep the mud out. Yeah, I don't know on that one. I don't normally, yeah, like I said, the only time I work with builder or decomposed granite or compacting is just for pre-concrete. So that one I don't know.
Right on. It's too bad you're not down here. I think we're gonna do that pour in the next couple of weeks.
Yeah, no, that's exciting. Do you know how big of a pad it is?
6.5 by 15.
Okay. There you go. Yeah, no, that'll be pretty good. Are you guys, how thick is it?
4 inches, and then at the four where the 4 posts are going in, the Simpson ties,
Yeah.
12 inches down.
Okay. All right. Yeah, no, that'll be a good little pour. Be a decent little chunk of concrete
How long would that take you to do though? Like a day? Half a day?
to like pour it out and finish it completely.
Yeah.
Do you know what finish you guys are doing on it? Or just doing like a broom, just a standard like broom finish, or
Probably something like that.
Yeah, less skid.
I would say if you had a pump, which because that's gonna end up being a yard and a half at most.
Yeah, I estimated it at 1.27 yards.
Yeah, I was gonna say probably order a yard and a half, a little heavy just in case. But I would say we had 2 wheelbarrows and 4 guys or like 2 wheelbarrows, 4 guys, 2 running wheelbarrows, 1 raking and 1 rodding, and broom finish. I would say if you got mud by 7, you'd be done by like 11:30.
So half a day.
Yeah, like half a day, depending
What
on.
if you don't have a pump, but you have a mixer?
Oh, that I actually don't know. I've never worked with a mixer really before. The only time I've used a mixer was for filling wow, I'm forgetting the names, not CML or CMUs.
Okay,
I did
guys.
4 yards with a mixture one time. That took like a whole day.
4 yards though?
Yeah, it was ridiculous. My dad didn't want to get a concrete. He didn't want to get a truck in because he was like trying to do like a low key project. So he had me and
Yeah.
my brother on a mixer, and
Yeah.
it was ridiculous. It was 4
There's
yards.
there's a whole range of stuff that's too small for, hand mixing and too small for a truck and too big for.
4 yards is way too much.
I know, you get in there and you, at the upper end of that, it's like, God, why didn't I get a truck?
Yeah, it was like 8 hours of just like picking up a bag, dumping it, wheelbarrowing it. But my dad was smart though. My dad was smart. When he loaded the trailer, he put the 90 bags in front. So before lunch, we were lifting 90 sacks. And then after lunch, it was a 60 sacks. And he's like, yeah, I put it in that way so that when you get tired, it's like you get a boost of energy. I'm like, oh, thanks, Pop.
So Jack, do you think a yard and a half is doable though?
Oh, I mean, so I did 4 yards with me and my brother, so that was like pretty much 2 yards each. I think if you have, you need at least 3 guys. You need a guy on the wheelbarrow and a guy mixing and a guy like lifting the bags. I think you could do a yard and a half. It's not too bad.
What about with a class, the beginning construction class of 15 people?
Depends on what beer you get.
Yeah, we're cutting this short. I got to finish my class. Hey, it'll work with a class, Lewis. Don't you worry.
You can do it. You can do it with a class.
One morning.
Yeah.
All right.
Or afternoon, depending on what part of Saturday people can come. Okay, so here's a slideshow. This guy, sometimes they give me a video and a slideshow, but this guy only did a slideshow, so that'll mean I can go through it faster, actually. I took roll, so that's all set. Okay, natural order of decarbonization and sustainability. What? Passive House, California. Okay. No. We don't even know about him. This is Passive House, California is an organization, apparently, whose mission is to promote awareness, understanding, application of the Passive House standard through education, events, advocacy, blah, blah, blah. Evidence-based, yeah, okay, we know that. Intelligence, yeah. Survival is back on the table, yeah. Okay, Passive House. The United Nations endorsed Passive House. Germany, they spell it PASSIF, Passive House, HAUS. So sometimes you see it that way. We've already Americanized it here. As a global standard at the recent North American Passive House Network Conference. So the UN's pushing it too. And they can be any, here's, I mean, this looks like an ordinary house, right? I think it's kind of a weird design having these right above that roof, but that's just me. Here's a multifamily drawing. I don't know which one's a passive house there. Oh, it's interesting. They did a city block in somewhere. Okay, we can go through this stuff. Oh, there's good old Albert. Passive house has arrived. That's kind of cool looking. Yeah, I'm glad we're not listening to his video. We have to go through all this.
I think you talking over the slides is better, Patrick.
It's faster anyway.
Yeah.
Well, there's a lot of stuff, you guys actually, because you've taken our classes at school, and the school itself, and with you, Lewis, and horticulture, the sustainabilities, you're more aware of all this stuff. So this guy doesn't know who his audience is, so he's kind of starting at the beginning. So we don't want to get too, yeah, passive house is passive. So that's one of the interesting things about it. Yeah, so here, and this can be on any house, but shading. So you've got a summertime solstice. These overhangs really shade the area, you can see, so that's good. And then in the winter solstice, when you need the heat's more back toward us, and it's missing the roofs and going into the house. So yeah, that's not just passive home, it does that, but Jesus.
Patrick, I know we're talking about airflow and air inside your house. Have you ever thought about indoor plants and how they might affect, oxygen content inside?
Yeah, well, they're producing oxygen and it'll be pretty pure, right? So yeah, I think indoor plants are really good. Yeah.
Yeah.
And they take a lot of carbon dioxide. Well, they'll take all the owners' carbon dioxide, that's for sure.
It's kind of a newer thing. I think a lot of people are getting into the indoor plants.
Yeah, for indoor air quality, it's definitely, it doesn't do everything because you've got, plants don't absorb all the toxins that are in the air. Unfortunately, they probably absorb some, but just the carbon dioxide is worth having around.
How does carbon monoxide affect plants? Is it like the same thing as carbon dioxide kind of from?
No, I think carbon monoxide is probably harmful to plants too. They may have a bigger tolerance, but it's definitely not. It's funny because they're only off by one oxygen molecule, but one's poisonous and one's life-giving. It's pretty amazing.
Yeah, well, most oxygen groups together in O2.
Yeah.
Like you never find oxygen by itself.
Yeah. Oh my God, this guy's he's more all over the place than I am. Can you imagine? Are we ever going to look at the basics? Oh, here we go. All right, here we go. We just cut off, 2/3 of this slideshow. The big three are airtight building shell. We know about that. Better insulation, correctly applied. We know about that. Mechanical ventilation with heat recovery. So because you're making the place so tight, you got to have mechanical assist to get the ventilation and the heat recovery we've been talking about. Again, this comes from Germany, which is a much colder climate in the winter than us. So they really want to recover that heat. Santa Barbara, it'd be interesting to see if passive, I met a guy years ago that I wanted to include in my green building class. He was doing some sites up by that Greek Orthodox church that's on the hill on 154. And he wasn't doing a lot of this kind of thing because it's just, that drastic in Santa Barbara, you know? Oh, here we go. One more comparison.
I'm gonna go get her. She's gonna be out of work in like 4 minutes.
What's that?
Or she's off to me, huh?
Yeah, please clean up this
Oh,
area.
Okay. Oh, sorry.
Hey, didn't they just say this?
Yeah, Patrick, speaking about insulation, did you put that rock wool in the wall? Did you notice the difference?
No.
No.
I in my house, I put it between on the inner wall for sounding, so I wouldn't notice.
And
The
it-
room's
and it-
quiet. It's quieter. The room's quieter. Yeah,
Hmm.
it definitely is a soundproofing. But I haven't put the stuff on Yukari's bathroom that you've seen because
Yeah.
I have to wait till the plumbers and electricians are.
I'm curious about how that.
Oh
Yeah.
yeah, me too. Me too.
Yeah.
Oh man. Okay, this is great. Here's a heat energy they call it recovery machine. And so the stale air from the bathroom, kitchen, and laundry go into it and cross over and leave its heat to the incoming air. And also so this is a heat energy recovery. So they should talk about moisture, which they don't. %90 efficient. That means it captures 90% of the heat in that outgoing air. That's pretty good, huh? So air that's coming in at 30 degrees, so we're talking freezing, comes in the house at 66. How do you like them apples? That's pretty cool, huh?
It's really good.
Yeah, you can see why these things, and the technology is really, duck, whack, whack, that kind of duck has this in their feet because their feet are in the water all the time, even in the winter, and they have to heat them. So they have the same kind of system in duck feet.
Do you happen to know how ducks survive in like Lake Tahoe in the winter and are still like swimming around in the water?
No, but they're one of many animals that survive in the winter, and God knows how they do it. They're really well designed.
Huh.
You got to hand it to animals. Those guys are, well, we're animals too, right? And we're such babies though now. A lot of us have dogs. Lewis has a dog I saw recently, and God, when you look at your dog, they're so much more fit for so many things than humans, It's kind of pathetic, really. But
True.
that's why we like dogs. We can aspire to something great, Okay, so those, okay, yeah, we agree. Those air-to-air heat exchangers are great. That's kind of be hard to read. So they do the usual sustainable things. They use LED lights. So that's scalable. Jesus. Yeah, so if you lived in LA where there's a lot of smog and stuff in the air, and here if the fires ever get any closer, but a lot of Californians had really bad air quality. And these houses, because the air comes in, and I think they have filters on them too, on these heat exchangers. That'd be good for that, huh?
Are there codes with the incoming air or the fans to have HEPA filters at all due to that?
I don't think there's any codes now for residences. There might be for hospitals, but or nursing homes, but you never know. The state can't do it because it's not a statewide problem. It's mostly in the cities and the lower Central Valley. God, I have friends who live in Visalia, and they came to Santa Barbara. They have a house here just to get away from the air because it was so bad. They're having that Sequoia fire, but they also get all the air from the Sacramento Valley and the San Joaquin Valley comes down to Visalia. So any fire that's north of there or any industrial pollution comes to the south of the valley there. It's really unfortunate place to live in those ways. Okay, and now we get a history of I'll spare you that. You'll get it in the next class, history of sustainability. Did Einstein discover all this stuff? Okay, begin early. So we'll talk about this in green building, but green building is very inexpensive and very competitive with regular building if you solve all the problems in the design stage. So they have these things where, what do they call them? Some pretentious, stupid name, where they all get together, all the subs, all the contractors, the owner, the designer, and they look at all the issues and they hash out what they want before they start building. It's great. We'll get somewhere. Oh my God. Natural order of decarbonization. I'm not sure what that. So energy efficiency is first because you don't produce carbon, and then you embody carbon. Trees do that, and then you electrify everything, and then you use renewable energy. So that's our decarbonization route for a zero carbon building. So they call them passive house. We'll look at another film later on zero net energy, and those are overlap. Zero net energy is sort of America's invention, but they overlap a lot. And then there's another one I'm missing here. Oh, zero carbon house, same. They're very similar, all of them. So heat, high efficiency heat recovery, ventilation, we just looked at that, air tightness. The other thing they have is high performance windows, really, really solid windows, because if that whole area is not approaching the insulation of the wall, you're just losing a lot out there. So in Germany, they all use triple pane windows because it's cold enough. And in the north, Santa Barbara would be overkill, but usually they'll have triple pane and really good. The triple pane is only part of it. You have to have good, the way the glass fits into the frame has to be really airtight. You have to use materials that don't transmit heat, like metals. So the high performance windows are really works of art, and they're expensive, but they pay off, especially in cold climate. Climate specific insulation levels, yeah, of course. Thermal bridge, this is another thing that they have, thermal bridge connections. So they'll tend to not just have insulation between studs, but if they do have regular studs, they'll have that, and then they'll have outside foam, that rigid foam that cuts off all the thermal bridging to the studs. Oh my God, is that all this is? What would be interesting, and I'll find it somewhere else, this doesn't have it, is the building, how they do various building components, like how they insulate. So all he'd have to do is put a cross section of a wall and, that kind of stuff. That film we saw by Rissinger the other day where he was using that spray thing, that barrier, what was that called? They were spraying, filling the leaks with that spray with a blower door pressurization. Remember that?
Aero
one
barrier.
of those, yeah, one of those houses, he was talking more about air barriers, and he mentioned the green, he had green sheathing that had insulation and had a coating that was an air barrier. And then you just had to tape the joints to make it work. And that was on heat on the outside. We don't want that. But those kind of details are what we need to show how the passive work. I don't know what I was going to say. Remember when I talked to you about he made that house, no rafter overhangs? He just had it come up, right? No rafter overhang, just had the wall merge into the roof. And then he added rafters over it, fake rafters. that's the kind of detailing Passive House has in a lot of places. Oh, this is it. Okay, I apologize. I'm sure you're all upset. I'll get some, there may be the zero net energy film. I'll preview it. I've got these spaced out in our classes. I'll look at the zero net energy. That probably has all that Passive House stuff, but the details are really interesting. I don't know why he didn't get into it. He was just kind of hyping the concept. But, in Germany, they use little windows because then you don't lose a lot of energy. But, Germany's got beautiful countryside and Americans love our views, right? So we're going with bigger windows, but they'll have to be, really stellar energy efficient windows, which we can get now. But all the other stuff in Passive House is just minimums, minimum insulation. So it might be more than the building code calls for now, maybe even twice as much. But so if you want to call your house a Passive House, you have to satisfy all the checklists of all things, right? Right minimum insulation, right minimum window value, right this and that. But that's just for prestige things. If you want to have a sustainable, tight, carbon neutral house, you don't need to call it a Passive House or even do all the things they do. You can do alternate things. It's just one, often people, when they hear a name and a program, they get on board. They like that. Oh, let's all do Passive House. So, that's fine, but it's not the only way to do it. And it shares the efficiency techniques with other houses. So it's not totally unique. They've packaged them in a certain thing, and I think their standards come from Germany, so they're pretty tight. It's for cooler climates than here. So you probably wouldn't want to do an official Passive House in Santa Barbara anyway. But I just want to make you aware of that because we're going to hear more and more about it. Okay, questions? Because that's all I got. 8:09. Wow.
Patrick, I have a question.
Sure.
Are we having a midterm next week since it's week 8?
No. I don't. If you probably noticed, I don't like to do what everybody else does. So I don't really give a shit if it's 7th week, 8th week, or 9th week. As far as I'm concerned, the days aren't even 16 weeks. We usually have holidays, usually 15 weeks. So they actually should come earlier.
You're going to just do it whenever it feels right.
Yeah, you got it. And so
Teaching by feel.
we're looking at next week's the 11th. Is that right?
Yeah.
So we're looking at midterm prep next week. Duct blaster diagnosis. I'll make that palatable. A little bit of HVAC interview. And the HVAC is so turning toward heat pumps all the way around that we're going to look at a heat pump video. And that one's good. That one's a more interesting video. It's a contractor on the job site and talking, and he's got slides. It's a much better. So we'll see that. And then there's another heat pump video after the midterm. That's also interesting. And so then the 18th we'll have the midterm, and then we'll have the midterm review with the smorgasbord of stuff. Heat pump to building safety, protection from the elements, and then we go into groundwater, windows, code requirements, and then final prep, and then performance as a career, the various agencies and opportunities for that. And that'll do it. So try to be here next week, although I'm filming it. So worst case is you can't make it for whatever reason, then you can look at the video afterwards, okay? But in terms of doing good on the test, nothing beats this prep because I pretty much give it away. Okay, any other questions?
Patrick, did you take call out roll or did you just take?
No, I knew who was here. I sometimes I happen just to check all your names. And some people aren't here now, but were here earlier, so I got everybody. Pretty much everybody was here. So yeah. So
What's the format of the midterm?
it'll be a Canvas test.
Mm-hmm.
And so I'll start it, if people want to start early, I'll open it up at like 5:30 and I'll go till 9 or 10. I'd like to go by 9 so I can go to bed, but I'm obligated to go till 10 if anybody needs the time. And I don't mind.
To start at
We can start at 5:30
5:30. Okay.
or even 5. We'll talk about it next week, okay?
Yeah.
Is
Do
it
you
in
know
class?
how long it's gonna be?
40 or 50 questions. I never go over 50, 40 or 50 questions.
It's not gonna be
I'm
like
not like other teachers in this program that go ape shit on the test. I mean,
This is why you're my favorite.
Human mortals were not made to work all day or go to school all day and come and take a 200 question test. That's just asking too much.
I'm afraid of his midterm and final, I'll tell you the truth.
Yeah, well,
If that was a quiz.
I want you guys, you're not going to learn any more by boning up for a stupid test. You learn the most by doing this, going through the review, the prep, taking the test and going through the review. I'm telling you, that's the way you'll learn it. If you learn it. So this stuff, I keep defending it only because I don't want people to get sour about this class. I mean, it's not the greatest class because it's online, but the material, you will use it in your future because you guys are all young and it's heading your way. This stuff's heading your way faster than you know it. And so you'll be able to, if your boss doesn't know it because he's old school like me. The only reason I'm not as old school as my age is because I teach this stuff and I keep up and I happen to believe in sustainability. Most old school guys don't. And so they'll never learn this. So you can actually train your bosses if you're working for someone and help them figure it out. So this will only be good for you. Okay. And so we only got a few more classes to suffer through. So, but anyway, we'll have the prep next week. So show up if you can. And with that,
Thanks,
there you go.
Thanks, Patrick.
All right. See you guys next week.
Have a good night.
All right. You too.